1 billion stars. This is the number that the European Space Agency mission Gaia will reach, mapping each star over 70 times to nail down their position, movement and characteristics. In the end, we will hold in our hands the most precise three-dimensional map of our galaxy. But how exactly will the mission measure such a vast number of stars? With its two telescopes, Gaia looks at two patches of the sky at the same time. A series of mirrors guides the light to the camera, the most powerful camera ever flown in space, with 106 CCDs and almost 1 billion pixels. When light from the first telescope reaches the camera, the first column of CCDs in the star mapper, on the right, selects the stars that will be followed and measured. When light from the second telescope reaches the camera, the second column of CCDs in the star mapper selects the stars that will be measured. As Gaia scans the sky, the light from both telescopes moves across the camera. But not all data need to be read out and stored. The onboard computer assigns a small patch or window around each star. As the image of the star moves across a row of CCDs in the camera, the star's position and brightness in this small patch on each CCD are recorded. This method is an optimization to deal with the enormous amount of data collected by Gaia's camera. Only a few dozen pixels on each CCD contain information about the star, so only those are read out and the corresponding data stored. The largest section on Gaia's camera is the astrometric field. As the image of a star moves across its 9 columns, each CCD measures the star's position and brightness. Then the starlight passes through two special prisms that direct different wavelengths to the two columns of CCDs in the photometer. This provides information about the star's temperature, size and chemical composition. Light from a subset of stars also reaches the radial velocity spectrometer, 12 CCDs that are used to measure how fast stars are moving with respect to us. For each star, the information collected by all CCDs is compressed into a data packet and stored in the computers on board Gaia. This process is repeated over and over for each star. An average of 2 million stars are measured every hour, generating a total of about 50 gigabytes of data every day. This is equivalent to more than 10 DVDs worth of information every day. The data packets for each star are transmitted to Earth, where they are received at the European Space Agency's ground stations. The data are processed and analyzed by astronomers, who use them to investigate the three-dimensional distribution and physical characteristics of stars. When all this is done, Gaia will have created the most precise three-dimensional map of our galaxy, the Milky Way.